So if I wanted to do, let's look at example number 3, where it asks me to find dy dx of the following function, y equals x to the 3t sine of t dt. All right, first thing I want to do is I want to take this x and I want to toss it up into the upper limit. Now remember, one of the properties for that is that I can flip it if I put the negative sign in the front. So in other words, this is the same as 3t sine of t dt. Okay, so that's the first thing I want to do. All right. So I can swap the upper and lower limits if I toss a negative sign in the front. So what I've done is I've taken this, put it up there, taken this and put it down there, and then put a negative sign in the front. Now I just want to take the derivative, or not? Oh well, yeah. So dy dx is the same as, and we're going to toss this -1 to the front, and I'm just going to let it linger there for a little while. Of course, it doesn't matter, but then I'm going to say d dx of this stuff, 3x, 3t of sine of t dt. Well, in the next line, the -1 stays in the front, and then I'm going to change that. Now that is really just 3x sine of x, and then the derivative of x prime, which is 1. Okay? So now if I finish this all the way through, I get -3x sine of x. Now I'm going to toss my dy together. So we got dy dx, dy dx. And that is it. Not too hard. Okay? So now let's do one more example, but now we'll do the same thing, but we're going to apply the chain rule. So let's find dy dx of the following function. Y is equal to, this is interesting, 2x to x squared of 1 over 2 plus e to the t dt. Well, what I want to do is I want to go, I have 2 x's, okay? And in order to fix those, I can take a boundary or make the assumption that 0 is between these. In other words, I could do something like this. I could say that y is equal to the integral of 0 to x squared of 1 over 2 plus e t dt plus 0 to 2x of 1 over 2 plus e to the t of dt. So what I'm saying is that I'm assuming that 2 times x is going to be on one side of 0, and x squared will be on another side of 0. Okay? Now, I can make that assumption based on the fact that in other words, 2x is a linear function. I can have negative values, so I could assume that if x is less than 0 or greater than 0 or it's positive, but I know for a fact that x squared is going to be a positive value. Okay? Now, because I've written it this way, plus I need to keep, because x is the upper limit here, so I need to keep that up here. Now, 2x is the lower limit, so I need to keep that in the bottom. Now, what I would like to do is the fundamental theorem of calculus only works if I have a constant on the bottom and the variable, in this case x, on the top. So I need to switch these around, which means I just put a negative sign in the front. So now I can evaluate from 0 to 2x of 1 over 2 plus e to the t dt. Now what you notice is that we're going to have to apply the chain rule because we have to consider the derivatives of those functions there. So in other words, what I'm going to end up with is that dy dx is equal to 1 over 2 plus e to the x squared times 2x. Whoops, I write a 2 there. Getting carried away. Minus 1 over 2 plus e to the 2x, and then I've got to tack on the derivative of 2x, which is 2. Okay? Now I could clean this up a little bit if I want to, but technically that's a good answer. I could say that dy dx is equal to 2x over 2 plus e to the x squared minus 2 over 2 plus e to the 2x. And that's my final answer. That would work.